Hello everyone, myself Shubhrata Saha, faculty of Dr. Sudhir Chandrasur Institute of Technology and Sports Complex in Department of Automobile Engineering, and today I am going to discuss about the topic of evaporative emission control, and this is one of the source of emissions by the engine by the vapor forms, and which accounts for near about 20 to 25% of total hydrocarbon emissions, and it's generally a leading source of hydrocarbon emissions. And the two main source of evaporative emissions are the fuel tank and the carburetor. These are the two main source of evaporative emissions. In fuel tank losses, as the temperature inside the engine rise, the fuel tank heats up and air inside the fuel tank expands, and the part of which goes out through the tank vent tube or leaves through the vent of the cap of the tank. Okay, and this air is mixed with the gasoline vapors. As the temperature decreases, the tank cools and the air inside the tank contracts, and there is more spaces inside the tank, and the air enters the tank and forms the atmosphere and ventilate that airs. This process of ventilation is called the breathing of the engine. Some of the gasoline engine is some of the gasolines from the engine is lost by the process of breathing, and if temperature is high, the most gasoline is the loss. In less temperature, the breathing of the gasoline may be less. These are the tank filling pressure. One more thing I want to discuss, that is the filling of the fuel tank. If when a partially filled fuel tank is open to the atmosphere, the partial pressure of the vapor phase hydrocarbon and vapor pressure of the liquid are equal, and they are in equilibrium also. If the temperature of the liquid is increased, say by the engine operations, and the vapor pressure of the liquid will be increased, and it will vaporize, and in an attempt to restore the equilibrium. As additional liquid vaporize, the total pressure is also important for the vapor losses. So from that chart we can see, if the tank is full with the ambient temperature of near about 22 degrees centigrade, can be zero losses. In quarter means less amount of, if you fill the less amount of fuel in the fuel tank, your ambient temperature may be less, but the losses will be high. So recommendation for a vehicle is for basically in gasoline engine, it's always full tank. The less tank fill is greater in the evaporation loss, and an approximate picture of the effect of the tank fill and temperature is shown and can be shown in this figure. Okay, so now evaporation loss control device. How you control your evaporation loss, and this control device aims at controlling all evaporative emissions by capturing the vapors and recirculating them at the appropriate times. The device, which are both are the same things, but in two different condition. First one is for the uh, condition where engine is stopped, and second one is the condition when engine is running. And it's basically consist the system is basically consist of an adsorbent chamber, or that is called the canister, uh, the pressure balance valve, patch control valves. These are the main component of this system. The adsorbent chamber, which consists of a charcoal bed, or and it's the charcoals are basically the porous in structure, and that porous structure, the fuel vapor can easily deposited on the surface of the charcoal pores. Okay, the carburetor and the fuel tank main source of the hydrocarbon emission. So when engine is not running, but the fuel presence in carburetor and the petrol tank, that may be continue to vapor, and what will happen, these vapors are going through the canisters and stored in the canister. These canisters are directly connected to the carburetor and the fuel tank also. The hot shock of the vapor is the hot shock conditions when a warmed up car is stopped and the engine is turned off. This results in some boiling in the carburetor bowl, and significant amount of hydrocarbon losses may be occurred, and thus the hot shock loss and also running loss from the carburetor as well as the tank are arrested in the chamber and absorbed there. Okay, so when we stopped our vehicle after a certain kilometer of running, the vapors which are formed in the fuel tank and also the vapors from the carburetors and the fuel tanks, that are already present in that conditions. So you can see here, these are the pressure balance valve. These pressure balance valve are restrict to flow of vapor of fuel into the manifold, and it's sent back to the canister. Similarly, from the petrol tank, it is also controlled by the pressure balance valve and also the patch control valve. And when the adsorbent bed or the canister bed is saturated to receive saturated with the vapors, and the action allowing in the air from the air cleaner to draw them into the intake manifold through the purge control valve. So by this purge control valve, when the the vapor of the canister, charcoal canister, is totally saturated. In that region, the vapor can be drawn by the purge control valve. The internal seats of the pressure valves at that time is so located that there is a direct pressure communication between the internal vent and the top of the carburetor, and which maintaining the design of carburetor metering forces. And when we start the vehicle, then what will happen? These pressure balance valves and the purge control valves will be open, and that case this saturated the vapors or the fuels from that canister can be drawn and sent back to the intake manifold. Okay, you can see from that picture. During the running conditions, and the fuels are coming back from the charcoal canisters and it's sent back to the intake manifold. So this is the evaporation loss control device. Now charcoal canister, as I told you, this is the canister, and the purpose of this canister is absorb the fuel vapor into the canister, and when it as per the criteria of the device, when the engine is running, that fuel can be drawn to the intake manifold as per the conditions, as per the desired condition. Now the charcoal canister. These are the picture of the charcoal canister. This charcoal canister used for trapping the gasoline vapors. Okay, and this type of charcoal canister is used to a evaporative emission control system of a gasoline engine, and fuel vapors from the float chamber of the carburetor enter into that canister through the left end passages from that passage. Okay, this left side passage is the vapor coming from the carburetor, and the fuel vapors from the fuel tank enters through the mid passage of this canister, and the flow of these vapors are shown by the arrows, which is toward the downward directions. When the engine is not running, the fuel vapor flows in this way. The fuel vapors are also absorbed by the charcoal particles present in the canisters. Here we can you have to know the terms absorber and adsorber. Absorption and adsorption, AB and AD. Adsorption means the particles which are deposited on the outer surface, and absorption, that is totally occupied or totally taken this volume and total thing is in a whole volume, that is absorption. And when the engine runs, air reaches the charcoal and canister due to the suction provided by the engine, and this air carries away by the hydrocarbons in fuel vapors to the engine manifold, and this purge action is also done in this charcoal canister system, and this is basically is situated in the right side. This charcoal canister is also known as the carbon canisters. Now, the modern evaporative control system. These are the modern evaporative control system which are used in a modern vehicle. A modern evaporative emission control system is situated or is taken the vapors from carburetor and the fuel tanks, and the fuel tank is fitted to the vapor liquid separators, which is in the form of a chamber on the fuel tanks, and vapor from the fuel tank goes to the top of the separator where the liquid gasoline is separated and sent back to the fuel tank or the fuel tank returning pipe. A vent valve or vent hole is also provided for provided to the carburetor for the flow of the fuel vapors. Okay, so through this vent valve, the vapors from the carburetor are drawn to the charcoal canisters. This vent valve is connected to the carburetor by a tube, and the fuel vapors from the float chamber flows through the vent hole and the tube to the canister. This canister absorbs the fuel vapors and these vapors are stored inside the canister. Adsorption refers to the process of trapping the gasoline vapors by activating the charcoal particles filled inside the canisters. Vapor-laden air from both the fuel tank and the carburetor passes through the canisters also. Hydrocarbons are left in the canisters due to the process of adsorption, and the air leaves from the canisters into the atmospheres. And when the engine is started, means at the time of off condition, or when we run a certain kilometers of the vehicle and stop the vehicles, then the vapors are collected from the carburetors, and in stop conditions the vapors is also collected from the fuel tank also, and these vapors are stored in canisters. So when we start the engine, the inlet manifold sucks fresh air through the canisters, and the fresh air purges the gasoline vapors from the canisters, and purging the process by which the gasoline vapors are removed from the charcoal particles inside the canister. Okay, so without proper design or without proper purging, you cannot draw the fuels from the charcoal canisters. So purging is also the very important technique. The air carries the hydrocarbons through the purge control solenoid valve to the engine induction system, and the purge control solenoid valve is also controlled by the ECM or ECU, electronic control unit. Okay, so these are the basics or the diagram or the operating principles of the modern evaporating system which are installed in the modern types of vehicle. Okay, thank you.